Well, hello friends. Welcome back to browser hacking. Today we're going to work on CSS stuff in Serenity, and it's going to be about computed style. And let's start by making a simple test case so I can illustrate what this will be about. And we will make a simple selector, set somebody's color to magenta, and then the last thing we're going to do is we're just going to get the computed style for this div here. And let's see, so foo is document get element by ID foo, and style is window.getComputedStyle for foo, and finally console.log style.color. So if we open this up in Firefox, for example, we should be able to see on the debug console here that it logs the computed color for that foo element. Of course, we can't actually see that foo element because it doesn't have any size. So let's make it a little bit more interesting by putting some text here. All right, so magenta. And maybe background color could be a cool thing to have as well, just to have two different things. And then I should remember that semicolons are a thing. Okay. So basically, computed style is the resulting style after the engine works with the CSS that you've specified, and then it applies the cascade and applies inheritance and all that stuff. And the computed values are the actual values that are used in rendering. So the computed color is the color that we actually end up showing on screen, and computed position and stuff like that. So today, what we do when you ask for the computed style for an element is that we just create an empty object in Serenity. So actually, let's focus on a single thing. Let's do only color. So if we open this up in Serenity, let me link it from the welcome page actually. Welcome. In the CSS section, I'm going to put that up top. CSS OM. That's the CSS object model. Computed style. Yeah, and then also I put it in the wrong directory apparently, so we'll just fix that quickly. Base res HTML misc. There we go. Okay, so let's open this up in Serenity, and I'll show you that we have some way to go here. All right, so CSS computed style. Of course, it displays in purple, but if you look down here, we just log an empty string. Nothing super interesting. So they're supposed to say the RGB value here, right? But if we look at what window.getComputedStyle actually does in our implementation, what it does is it just creates an empty vector of properties and an empty map of custom properties, and then it creates a style declaration object to wrap those two empty containers. And that's the object that you then get back. So when you then try to ask this thing for actually I had it here, right? Yeah, style. When you try to ask it about any kind of property like display or color or whatever, it will just say empty string. So there are a bunch of things that we need to do here. And I guess I should mention that we do already support one type of style declaration access. So maybe we should expand the test to cover that actually. Right, so what we do support is if you have a style attribute. So we'll make a bar thing that has a style attribute. And here we'll put color green, say. And what will happen here is that we can't get the computed style for this guy, but we can get the specified style by checking, let's see, so document get element by ID bar, and then that is in bar.style.color. So the specified style declaration is available on the element itself. At least that's how I recall that working. Let's maybe double check. Get computed style is not a function. Oh, wait. What did I screw up here? Not doing that right. Oh, not get computed style. That's not what I wanted to do. I wanted to get element by ID. All right, yeah. So green. And actually, this is a pretty good illustration of what I was talking about, the difference between computed and specified style. So green is specified style. It is not canonicalized by the CSS engine. So here you get whatever it says, however the property is specified, that's what you get. Whereas with computed style, it goes through this canonicalization phase in the engine. So it comes out like this in Firefox, and we'll see how we make it come out. I think that's probably the best format. Computed style. And oh yeah, and we are just I think I messed that up because I didn't rebuild the disk image after changing the file. Yeah, so this is how we give you the thing apparently. So it seems like we don't actually report verbatim what it says here, while Firefox does. Instead, we canonicalize into this kind of unusual format, which now I have to check web CSS RRGGBBA. Does the web platform actually support that? I don't remember. I feel like they added it at some point. I guess they probably did. But that's not what we're here to care about now. What we're here to care about is getting the computed style. So what's supposed to happen here is that we're supposed to instantiate a new computed style object, or a new CSS style declaration object, as we're doing here. But instead of having an empty set of properties, it's supposed to be a live view of the computed style of the element that we've provided. So it can't just be a snapshot of what it looked like at the moment, but it has to be live. So that's a little bit weird, but many things in the web platform are like that. Like collections, for example, are also live, many of them. But that's just something that we have to deal with. But I think one problem is, the first problem that we're going to have to deal with, actually, is that the CSS style declaration object is quite simple. It's just it has a vector of properties and a hash map of custom properties. But in the case of a computed style declaration, we don't want to have a vector of properties and stuff like that because it's supposed to be a live view. So we're better off just having a pointer to the element. And then if somebody queries us for a property, we'll just go and figure out the value for that property at that point in time. So this is not really set up for this. So I think what we want to do here is we want to create some subclasses and virtualize this whole thing a little bit. And the first thing that comes to mind is we should take the way that it currently works. So this this version of style declaration where it manages the property storage itself, let's put that into a subclass. and then we will virtualize property access. And finally, we can then add a new ComputedStyle subclass that has a pointer to the element, and then those virtuals can be overridden there to go and do the property lookup. Yeah, so that's the immediate plan. Let's get to it. So I guess we'll call it something, and we can just put it here for now. So we'll call it like property owning CSS style declaration. And public, and I think essentially what we want here is some access interface, like to this thing, so that you can do a lookup by property ID. And we want this to be virtual, and we want it to be pure virtual, actually. And then we'll also have a set property that takes a CSS text input, where you can just give it a CSS value string, and then it will parse it. And if it fails to parse, then we can just return false, and then it's up to the client to deal with that. Yeah, I think that'll be good. And then the subclass can just go ahead and override these two. And then the subclass will have these things. And I guess the length getter also becomes virtual. Yeah, it has to be. Properties, size, and item. I don't even know what that is. Item. Who uses that? Oh, that might be exposed actually. We should look at the way that this interface is exposed to the web, because this is specified. Yeah, item is a thing actually. So it returns the CSS property name from a style declaration by index. Okay, that's a little bit of a strange API, but it's something that we have to support. So I guess we will just, yeah, we'll just have it virtual like that as well. And let's see. I'm just thinking maybe we should put these in the CPP file. I don't have to get wild here with stuff in the header. So let's have a factory function. We'll just use this one right here. Property owning style declaration. Yep. Okay, custom property count. All that stuff has to move to property owning. And the factory function in the base class goes away. So nobody's going to be instantiating this thing anymore directly. But instead, we will simply have an empty base class constructor like this that others can instantiate, and then wait, why don't you like it? You don't like it because requires 1 argument, but 2 were provided. Okay, well, I'm messing something up somewhere, but it's not immediately obvious what it is. Okay, well, we're gonna figure it out. Expected paren. Is the whole thing because you think it's not final? What? Okay, so why are you abstract? Oh, the constructor name is wrong. Oh. Okay, that was stupid. Abstract class is marked final because missing length, item, property, and set property. Oh yeah, because this guy here should just inherit from the property owning thing. Okay, so finally making some progress. Then let's go ahead and implement these. So element inline CSS style declaration, by the way, it's a subclass that represents element.style. So the stuff we just looked at. Element inline CSS style. Yeah, we have to figure out how to cooperate with that thing. But let's see. For now, we are just going to make this thing actually work, and then we will think about the details. Wait, what did the previous one do? Item. Oh, it's implemented here somewhere. Item. Okay, yeah. So we can just rename this actually. And this should be protected because it's used by subclass. Sure. Yeah, we didn't actually need that. Okay, so let's implement these property lookup thingies. And basically what they will do is they will just iterate over the property storage and fetch a property. So properties, oops. If the property, wait, what do we have there? Property dot property ID is property ID, then return property. If we don't find it, return empty optional. Okay, and then for setting the property, let's see, how do we do this? So style declaration wrapper. This is the JavaScript handler when you try to set the property on this thing. So then we end up here in an internal set. So I think this logic right here is what we want. It gets the CSS text and then passes it to the CSS parser. So yeah, this stuff just moves into this thing right here. Okay. Then we need to include the parser. Okay. Yeah, so this initial refactoring here is a bit mechanical, but we will get to the next part sooner or later. Okay, so that seems sensible. We're just moving the setting logic from the wrapper. Actually, I guess we can move it. We can port the wrapper here to using, because you see here the internal get for the JavaScript object actually also walks over the properties and checks the property ID, and if so, returns the value. So we can actually do the same thing here. Maybe property is impl property ID, and if maybe property has a value, then return JS string, create a new JavaScript string, maybe property value to string. Otherwise, return the empty string. Yeah, and then here, when we set, we just call set property. Oh, that actually worked out really, really nicely. And then we don't need that, whatever that was for. Cool. So the element inline CSS style declaration constructor behaves a little bit weird in that it takes the fields from an existing declaration and sort of yoinks them, moving them into itself. So let's see how this is actually used. Create and take properties from, right. I have a recollection of somebody adding this per my request. So let's see. Okay, so this is when you assign the style attribute on something, then we call the CSS parser, asking it to parse the CSS declaration with the string you just assigned to the style attribute. And if that works out, then we create a new inline style object. Oh, with the I see. Right, because the parser returns a plain CSS declaration, and then what we want is an element inline style CSS, element inline CSS style declaration, which is a subclass of this thing. So actually the parser should be taught to return these. So let's make sure that we do that. CSS style declaration. Yeah, we just have to use these things. So the because the parser doesn't care about a computed style. The parser just has to produce a declaration that owns its own properties. So that would be fine. And then what we were forgetting now was, oh, this stuff, right? I guess we can just do that. And then we have to be friends with that class, I guess, for that to work. I see, that's why this was going on right here. So they had a friendship. I like to put friendships up top. Makes it very visible who your friends are. I don't think we need that friendship, so let's get rid of it. And have a look now here, see what we're screwing up. Okay. Wait, let me. There's one first error. Property owning CSS style declaration. Oh, it doesn't know about it. Oh, I see, I see, I see. We have to forward declare it somewhere. Presumably in web forward. Element inline style. Oh yeah, yeah. So it's all here. We just have to have a forward declaration of property owning. Maybe there's a better name for this than property owning CSS style declaration. It's a bit of a mouthful, but we just need to call it something. Okay, and then custom properties become an issue. Right, what do we do about that custom property? So computed style is not going to have custom properties because it's computed. So all of that stuff will have been processed at that point. So what does it want with that custom property? Well, let's see. So I guess here, what we can do here for now is that we can cast to a property owning style declaration. It's not the most beautiful solution, but it does sidestep that particular issue. And then we have a similar thing here. So when we're resolving the style for an element, that we know for sure that we're not working with computed style. So we can actually do these casts here. And then we don't have to come up with more elegant interfaces for these things right now, which is very nice. Okay, so element inline style, that's going to be an element inline style will be a element inline style CSS, element inline CSS style declaration. There we go. Okay, then we have some debug dumping code that needs a little bit of help. Same issue here, we can just cast. I think we need to qualify that a little bit better. There we go. And then DOM window. Oh, this guy doesn't exist anymore, right? Okay, so we're almost, I feel like we've almost gotten rid of all of the basic build issues here. So at this point, what we have achieved, hopefully, is that there's now a CSS style declaration base class with a bunch of pure virtual functions. And then there's a subclass called property owning CSS style declaration that owns a set of properties. And this will then allow us to create another type of subclass of CSS style declaration called computed CSS style declaration that instead of a list of properties and values has an underlying element. And then when you try to query it for style, it will go and ask the element, what's your color? Stuff like that, roughly speaking. So let's see if we can make that into reality. Oh, we are missing a destructor for this guy right here. I guess I can put him right here, property. Okay, so let's see that our test case still works. That refactor took a little bit longer than I expected, but it's probably all good. All right, so it still looks the same, still comes out the same here. I would say we're in a good place. So let's go ahead and do some basic commits. So yeah, we'll just do everything here in one chunk. Yep. Okay, yeah. That's fine. So libweb. Oh, what did we miss? Oh, you wanted that to... Okay, fine. So libweb, make CSS style declaration a pure, an abstract class. This patch moves the CSS property and value storage down to a new subclass of CSS style declaration called property owning CSS style declaration. This is the JavaScript wrapper for CSS style declaration now calls virtual functions on CSS style declaration on the C++ object, let's say. This is preparation for supporting computed style CSS style declaration objects, which won't have internal properties storage, but rather an internal element pointer. Yes, that's exactly what that is. Okay, well, that was a bit of a hassle. So let's just add this very simple test page to our test page repertoire. Add a very simple test page for getComputedStyle. Okay, so now we can finally start thinking about adding that ComputedStyle style declaration object. So let's make one. We'll call it a computed CSS style declaration. Yeah, computed CSS style declaration. It's a bit of a mouthful, but that's usually something that we don't frown upon in this project. That's the wrong file. So you are gonna go right here, I guess. Boom. Yeah. Okay. So what on earth is a computed CSS style declaration? Well, let's figure that out. So we'll start with the basics, namespace, web CSS. And then, of course, we will want to pull in the style declaration class, and computed CSS style declaration will be a final class inheriting from CSS style declaration. And it will have a, let's look at private members. So we'll have a non-null ref pointer to a DOM element, which is the underlying element from which we'll retrieve style. And it needs those virtual interfaces that we added to style declaration. So these things right here, we have to override. Ploop. This becomes the thing that we do. Not completely sure how we're going to deal with length and item. I guess the declaration needs to behave as if it has, you know, however many properties we could actually look up. So if we know about 200 properties in the engine, I think we're supposed to act as if this declaration has 200 properties, even though they are going to be computed on the fly. But I think we will probably leave these particular APIs as to-dos for now. But we'll see. Yeah, and then we need a factory function. So non-null ref footer computed create, and it will take an element, a DOM element, and new computed thing with the element as input. All right, and then what we do here is we just need a constructor. So explicit computed DOM element. Okay, wow. Finally, we're writing some new code. That previous thing was a bit of a drag. All right, and then in the CPP, oh, that's a screenshot. That's not the button I meant to press. Let's see. Computed, sure. Name spacé, web CSS. No, not a new class, just the constructor and the structure. Sure, and then we just assign to element, and the computed style object. Let's just make this simple by having it strongly own the element. I think that's fine. Like even if the element goes out of scope, like nobody else uses the element. It's been removed from the DOM and everything, but we still have the computed style object around. I think it's fine for that to keep the element alive. That's not going to hurt anybody. If you're holding on to computed style for an element for whatever reason, we're not going to get in your way or take the element from you, because that would be a bit nasty. Of course, if you remove the element from the DOM, the computed style will not be very interesting anymore, but that's a separate issue. So yeah. So our length, that's pretty simple. Let's just say 0. And same thing for the item thingy, which was just meant to get the property name at a given index. We'll just return the null string here. And then we had 2 more APIs. So optional style property with the property ID, and also a bool. If you try to set a property, so I think if you try to set a property on a computed style, we will just say, nah, you cannot do that. That is not meaningful. Because you can't change the style of an element by assigning to its computed style. You have to either update your style sheets or the inline style attribute on the element if you want to change the style of an element. The computed style should not be mutable in that way, as far as I know. So then to get a property, so this is the real trick, because when we take in CSS, we turn it into a bunch of different internal representations, and we don't have like a simple thing that we can just, oh, we'll just give you this thing. We have turned some CSS properties into enums, others into these big objects, and we are just going to have to, I think we're just going to have to go property by property here, which will be a little bit messy, but I think it's the best we can do. So the first thing, though, we should figure out if the element does not have a layout node. Because if the element does not have a layout node, then it doesn't have any computed style at all. Or it's effectively display none, I guess. So, wait, what does that even mean, actually? So I guess if property ID is property ID, what happens if you have display none for something? We're gonna have to test this out in like Firefox. Invisible. Okay, I'm not gonna spell that wrong because somebody will yell at me. Display none. Let's say. I wonder what the style here will be. Console log invisible. Or the computed style is what we want. So window.getComputedStyle invisible dot display. What is the computed display value of a display none item? That's what I want to know. Oh, wait, shoot. I moved that file. Right. Misc. Okay, well, I screwed something up again. Oh, I didn't make an element. Ugh. Invisible. You cannot see me. Hopefully. Okay, so we should actually return none for that. Okay, so it's not as simple as like, we can't just bail if you don't have a layout node. What we'll have to do, I guess, is we'll just have to switch. So CSS case property ID display. So we'll do something here, and then property ID color. Okay, so the color one, we can start with that one. And wait, what happens here? You don't like it because you need a default case, right? Yeah. So let's start with color. How the heck do we get the color? Well, we need the element layout node computed values. Yes, color. And then we have to turn that into a string. Aha. Okay, so this property requires, oh, we have to make a style property thing, actually. Style property. Let's say computed property. Can we just make that way? You don't like it because you have to have a style value. Okay, this is a bit hairier than I expected. All right, that's fine. So we have to include some info here. Value is style. Oh, what did we turn this thing into even? Style, color value, color style value. That's what I'm looking for. Color style value create from this color. All right. And if we don't have a layout node, then what happens in Firefox if you're not visible, you try to look up the color of something that's not visible, then what happens? Color. Oh, it still gives you blue. Okay. Oh, damn. Okay. I don't know why I thought that it wouldn't give you back anything. Because the computed style, I guess, is still going to be blue, even though we ended up not rendering it. I don't know why I'm so... This might be something that I remember from working on WebKit back in the day. I feel like maybe WebKit had a weird idiosyncrasy where elements that didn't have a layout tree node ended up not having an ability to reflect computed style or something like that. And interestingly, since we inherit many of WebKit's designs, that's kind of a problem that we find ourselves with right now. Because if we don't have a layout node, then we haven't stored the computed style anywhere. So we are kind of shit out of luck in that case. We would have to actually, I guess if we don't have a layout node, what we could do is we could perform a style resolution and then give you the style color from that. Okay, well, let's just make that into a, for now, we'll just say nothing. Fix me, this should actually return computed color. Yeah, that's a design problem that we have to deal with. Okay, let's see if we can get this working though. So, will this build, I wonder? Did I put a pragma in my CPP file again? Style computed. Wait, where? Oh, just pragma. Oh, I see. And I'm forgetting a thing. Is it? I have to say break. And I have to return something if I don't go anywhere. I guess we should do that there, actually. Yeah. Yeah, so this problem is a bit tricksy. So what's happening is that we store all of the computed style values with the layout node. And because display none tells us, oh, this thing does not participate in layout, so then we're like, oh, well, then it doesn't need a layout node. And then as an effect of that, we don't have the computed style information stored anywhere because we figured we were not going to need it. Oh, it breaks out here. Right. Well, actually, I mean, all of the cases should return. So the easy solution maybe for this would be, as I was saying, that we would perform a style resolution, which is what the layout engine does when it tries to build a layout tree. Then it will go to each element in the DOM and say, what would be the good style for you, dear element? And then we run all the selectors and figure out, oh, these different style rules apply, and compute the style based on that. And then after that, we look at the display property that we just computed and say, oh, well, it's none, so we throw everything away. But maybe what we should do is do that here. So computed values, we can't use that. We would have to use something else. So where did we get it? Okay, well, I don't exactly know how we're going to solve this, but we'll figure it out. Let's see. Computed style. Okay, so all of them are still empty. It's not great. So let's see if we are. Oh, but we have to teach window to actually produce one of these things. So window.getComputedStyle still returns this stupid empty thing. But instead, we want to create this new fancy thing, the computed CSS style declaration. Man, there's a lot of S's in a row here. Bloop. And I need libweb CSS computed. Yes, that's what we want to do. It's funny, like all these little unintentional things that we're inheriting from WebKit just because I'm so used to the WebKit engine from working on it in the past. Stuff that I totally forgot about or never considered. And like now, many years later, I'm realizing, oh, well, that's going to be a problem because this, and that. These things would have been good information back in the day. Anyway. Okay, so we're still not getting any output for the computed style. Let's at least log that we are here so that we can see that we're ending up in the right place. Get computed property. String from property ID, sure. I just want to see the name of it. Also, I guess this thing has more fields, but the other fields are not as important, so. Get computed property display and color. Okay, making progress. Let's see if we have a layout node. It might be that we don't even have a layout node at this point, actually, because we are still in the parsing stage. Because our script is running. Oh, that's kind of silly. Our script is running before a layout has occurred. But I just realized that when you do a property lookup, it has to have current layout information anyway. So we really actually have no choice but to synchronize the layout. Let's just document. Can we update the layout immediately here? Because we need to have the layout information. Force, no, what the hell is it called? That's, I forget what it's called. Document H layout, force layout. That's the thing I want to do. Force layout. I can't do that because I'm in a const thing. Okay, well, we're just gonna punch a hole in this thing right here. Yeah, you are just gonna have to accept that. Okay, so by forcing the document to do a layout, we ensure that, or we should ensure that we get current information for everything. So kluk, and finally we get some output. So the very first thing is the computed style color for foo, right? This test case here got a little convoluted. Also, why is this syntax highlighting so broken in Vim here? Let's see if we can fix that with some better markup, maybe. Body, I don't know. It's an HTML file. Why does it look so bad? Oh, there we go. Okay. Just Vim was confused, I guess. Okay, so we have foo, and let's call this foo style. Bar style is bar style. Visible style is get computed style for invisible. Yeah. Just making that a little bit easier to follow. Okay. So we are correctly handing out the fact that this is magenta, right? Red, blue, full alpha. Totally opaque. All right. Excellent. So we have successfully produced our first computed style output. So I'm just gonna actually just patch this into the preceding commit there, just cleaning up the test a little bit, making it a little bit nicer. And yeah, the fact that these don't work right. So what is the fallback? Fallback is we need a style resolver. This could become prohibitively messy, but let's test it. Style resolver. Oh wait, we have the element document style resolver. Resolve style for the element, sure. Wait, is that? I wonder why it is a mutable reference. I don't know. I'm not going to ask that question right now. We're just going to plow forward and take a closer look at this. So you don't like that because you want me to do that, sure. And what does that return? It's a non-null ref footer. Okay, so it definitely returns something. So now if we resolve the style for this thing, property is style, property, well, maybe this is some kind of a generic fallback mechanism we can do actually. Property ID, right. So you ask for that, and then if that's optional. Yeah, right. So maybe property. Okay, so we have a value, and then in that case, we will return style property. And the value is maybe property release value. Okay, and then we need to wrap this whole thing in a lambda. Specify property if available. Yeah. And then we'll make a little lambda helper for this. Specified property if available. Actually, we don't even need to pass the property ID because we have it from capture here. So, but we do have to say that it returns an optional style property. Sure. Okay. Yes. So we'll if we don't have a layout node, we fall back. Oh, well, actually, then I guess we can do that in any case if we don't have a layout node. Yeah. So this doesn't even need to be a lambda. We don't have a layout node. Do a manual style resolution. Return the specified property if one is available. Otherwise, return nothing. Seems totally reasonable. There's a lot of stuff in the CSS OM spec that we are like ignoring right now because we're just trying to get the basic mechanism into place, obviously. All the finer details come later, but sometimes you have to sketch out new things. See, style is not defined. Oh, did I screw up the test page? I probably did. Damn it. Still called style somewhere, isn't it? Style.color. Yeah, that's my bad. Foo style. Okay, well, I'm happy with that fallback mechanism that we came up with there. Now, implementing all the various properties is going to be a hassle, and now I broke that color. Dang it. Okay, so how did I do that? If the element doesn't have a layout node, but it should have a layout node. Wait, does this work in Firefox now? Yes, it does. All right, so why did I break it? How did we break it? Computed. Yeah, and then let's log our layout node. Okay, and that will tell us which path we're taking. Oh, well, now it's taking a much better path. So we actually get everything looking all right. Interesting. Okay, so first the computed color comes out here, magenta, the first one. We have a layout node, and then we get the green for the bar thing, and then here for the lookups where we don't actually have a layout node. These are very interesting. In those cases, it still works because we get the specified style. It's none, display none, and blue. Excellent. Yeah, so the case now that doesn't actually work is if you have display, but and it's not display none, because then you'll end up here and we have to actually figure out what the display value is. So in that case, we need to, let's see, element, I guess we can do this. Auto layout node is element layout node. At this point, we know we have one, so we can tidy up this code a tiny bit here. So switch layout node, computed values, display. Yes. You want me to have a bunch of cases? Yeah. So display. And then I just have to handle all of these. So this is something that would be nice if we had saved somewhere in a handy helper. Also, I'm gonna have to make a handy helper actually. This is stupid. I don't want to have all those in line here. So let's just make a handy helper for this particular thing. ToString CSS display. Is this something we have already? Just checking. Seems like it's not. All right, fine. These are the values that we have to support. Sure. Okay. Let's do that multi-cursor thing that people always tell me about. Damn it. Scrolled all wrong. Oh, why the heck? C-line, come on, man. All right. Somehow we managed to do that blind. Okay. That's fine. Yeah, and then let's just do these. Obviously, we should generate this somehow better, but just this once, let's allow ourselves to be a little bit ad hackish. Table row. Table header group. Look at all these rare CSS display values. Table footer group. Bet you didn't use that recently. Table dash column. I just have to double check that this is what it's actually called. Table footer group. Yeah, that's what it's called. Yeah. All right. So we have that, and then all we need to do at that point is to just call this thing. Oh, damn it. Wait, we want to turn this into a style value. I forgot about that. We want to make an identifier style value. An identifier style value wants a value ID. Okay, dang it. So what we want to return here is actually CSS value ID none. To CSS value ID. Dang it. Okay, well, I could have done this a bit smarter then. So let's just this is outside of what I will regex. It's not enough, not enough items here that I'm going to try to not regex this. I mean, I would regex the final fix-up where we switch display to value ID, but table header group. It's probably at least one person right now looking at this saying, "Oh, why don't you just press the magic button that does this thing?" But I'm currently not aware of the button I'm supposed to press, so we are doing it this way. You can only get so fancy with multi-cursors. I probably could have done this with multi-cursor somehow. It's just I'm blacking out on how right now. Okay, flex, and then return CSS display becomes return CSS value ID. And there we go. Okay, and then we have, what is it that we have? We have the layout node computed values display. Okay, and then we need to actually add, we need one more thing, something that's actually visible. So not display none, and we want that to have computed style visible as well. You can see me. Yeah, because this guy is going to be like display something else, like display, how about some of them block? Color will be red. Well, that barely compiled because we need to say static. And we also need to, wait, what? This thing can, So what do we get? When we click on the thing, you can see me. It does not appear red though. But it doesn't get red here either. Where did I even put red then? Color red. Oh, display. What am I even doing? All right, there we go. Okay, well, this grew very organically here today, but I'm still pretty happy with the progress. Yeah, you can see me, and it comes out computed color looks. We get the computed block string for the display property, and we also get the color coming out right. So, all right, I think we figured out the most difficult questions here. We have figured out. Obviously, now it's going to become a project in itself to add more properties, and certainly some properties are easier than others. Like a color is easy, but more complicated stuff is like font and various metrics. But I have to start somewhere, so we started with color and display, which we can now compute, and I think that's fantastic. So very happy with the progress. I'm going to amend one more time into that test file. Oh shoot, wait. Is that actually? Yeah, that was the last commit. Okay, and now we are ready to commit our new computed style declaration class. So libweb, add a computed CSS style declaration. Support some two properties. Window.getComputedStyle element now returns a computed CSS style declaration. Okay, well, we can just do that. Object, which is a live view of the computed style of an element, of a given element. This works by computed CSS style declaration being a wrapper around an element pointer. When you ask it for a CSS property, it gets the latest computed style values from the element and tries to return them. Yeah, it returns them as a CSS style. What the heck did we call that? Style property object. In this first cut, only adds support for color and display properties. All right, computed color and display, let's say. In case the element doesn't have a corresponding node in the layout tree, we fall back to using specified style instead. This is achieved by performing an on-the-fly style resolution for the individual element and then grabbing the property, the requested property from that result style. Yeah, so interestingly, if you don't have a corresponding layout node for your element, then all properties work. Whereas if you do have a layout node, only these properties work. So actually, we should probably add one more thing here. So to do computed style for the property was requested. Yeah, or let's even say fix me. String from property ID, property ID. Yeah, I think that's a very helpful thing to have. Let's put that in a separate commit. Log a fix me when unimplemented computed style is requested. This will help us know which properties to compute next. Okay. All right. Wow. That turned out pretty okay, I think. So I think this is going to be the end of today's video. And I'm really happy with the progress, although that initial refactoring was a bit cumbersome, but we got it to a good place. And then we got the computed style wrapper around element working. And now it produces good output. Of course, we don't give the same output format as Firefox does, but that's not actually required. As long as the parser can reparse whatever this thing gives us, then it's fine. So as long as these outputs here work as inputs into our own parser, then it doesn't really matter. I mean, they should work as inputs into Firefox's parser as well, and we can handle these inputs. But as far as I know, there's no requirement that you serialize these things in a specific way, as long as they're understandable. Okay, so that's the end of today's video. I hope you saw something interesting, and thank you very much for hanging out. I will see you next time. Bye.